Okay, so today we're going to play a little bit of maths. We've gone through this cube, which on the inside has a measurement of 10 centimetres by 10 centimetres by 10 centimetres, which is the same as 1 decimetre by 1 decimetre by 1 decimetre. And we filled the bottom here with 90 of these little yellow 1 centimetre cubes. Okay, we've got 10 along here and 9 along here of yellow, and then I put in a 10 here as well, just to make it a little bit easier to get them out. So on the bottom there are 10 times 10 centimetres cubed, and this is how small a centimetre cubed is. And then if we were to fill this up with centimetre cubes, here's another 100, there's 200, 300, 400, 500, 600, 700, 800, 900 more, okay? No, not 900 more. We need to put these in as well. We've now got 900. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to make this 1 full litre, 1,000 centimetres cubed, we'd have to put in our last 9 lots of 10 plus our tiny ones, and we would now have 1,000 centimetres cubed. And then some great scientists came up with the idea of, okay, let's standardise this. Let's call this 1 decimetre cubed, let's call it litre. So a decimetre cubed, which is 10 centimetres by 10 centimetres by 10 centimetres, or 1 decimetre by 1 decimetre by 1 decimetre. Let's call this 1 litre. Okay? So a litre of milk is the same as 1 decimetre cubed of milk, which is the same as 1,000 centimetres cubed, which is also the same as the volume unit, 1,000 millilitres. Because milli means 1,000, so 1 litre and 1,000 millilitres are the same thing. And 1 decimetre cubed and 1,000 centimetre cubed. So I just thought we would have a little look today at what does that actually mean. Here we talked about pyramids, and I told you that in order to calculate the volume of any shape, we take the base area and we multiply it by the height, the vertical height. Well, let's investigate that. Let's see if it's actually true. We've got a shape here, and it looks, we need to take the internal measurements. Here we have 100 millimetres, and the internal length is also 100 millimetres. So we have 1 decimetre by 1 decimetre by 1 decimetre. Let's actually check that it is a litre then. So let's fill it. All the way up to the top, if I had enough water. That would be so good, but I don't. So I'm sure we're going to get some more water here in a second. So until then, we will investigate a pyramid. Okay, here's a square base pyramid. This one has the same dimension on the base as this. Now, I told you the other day what I thought the formula was. Who remembers what the formula was for volume of any pyramid shape? Anybody remember? Yeah, Rick?
It's base times the perpendicular height divided by 3.
Yeah, so the area of the base times the perpendicular height divided by 3. Let's see if it is. We should have enough water to fill our pyramid at least. So let's try and get it up to the top. Now this is the trick of me trying not to spill it. We know that it's got the same area as this, and it's almost at the top there. And we can see that when we fill it into our cube, we get about a third of it is filled. So we have shown that we've got a third, and let's actually measure it a little bit more accurately. If we actually fill into our measuring cylinder here, we're expecting about 330 centimetres cubed, or 330 millilitres. So why would I pour it into a 250 Wendy, measuring cylinder, yep. Let's try it here. Here we have 300 and, need to get an eye level to measure the lip. 330 centimetres cubed or millilitres of water. So we've just proved that it is true that the volume of a pyramid is still the area of the base times the perpendicular height divided by 3. Let's check that there was actually a litre in this by filling up the whole square. Super sensible to wear white clothes today when we're playing with red food colouring. Not. So, fill this up. Okay, with a little bit of spillage, but here we are at around a litre. Next one. Now we have, what do we have now? Now we have a cylinder. Okay, what do we know about the volume of a cylinder? What's the formula for volume of a cylinder? So this was the formula for a square-based pyramid, that we had the base of 10 centimetres by 10 centimetres to give us the base area here, multiplied by the perpendicular height, which was 10, divided by 3. So we were expecting the volume of our pyramid to be 1,000 divided by 3, about 330 centimetres cubed, which is about 330 millilitres as well. So that worked for pyramid. Let's see if it works for cylinder. Cylinder has a different formula. It's not quite as easy as just working out the square area. What's the formula for a cylinder? Anyone? The volume of a cylinder is calculated by the base area, which is pi r squared, the area of the circle, multiplied by the perpendicular height. Okay, well then we need some measurements, don't we? So we need to first of all measure the diameter of this cylinder. The internal diameter is, oh surprise, surprise, it's 10 centimetres. So what's our radius? Always remember half of that. So we've got pi as 3.14 times the radius, 5 squared, times the perpendicular height. I would expect it to be 10, and it is, times 10. So, calculator. So we have, we're expecting a volume here, 3.14 times 25, 250. Of?
785.
785 centimetres cubed, which is the same as 785 millilitres. Now first I thought we'd do the cone. What would we expect for the cone? We'd expect the cone to have the same volume as the cylinder, because it has the same base area, these ones fit, but divided by 3 for a cone. So the volume of our cone, we'd expect it to have the same base area multiplied by the same perpendicular height divided by 3. Well, we know that it's going to be the area times the perpendicular height, we're expecting it to be 785. It's the same radius of 5 centimeters, and it's the same perpendicular height of 10 centimeters. So the only thing that would be different here would be that we'd expect it to be a third. Let's fill in a third of this first. Let's fill in our cone and see what volume we get. Yes, watch out. Okay, that bit's easy. Looks about a third of the cylinder, doesn't it? 1/3 is filled by the cone. That means that 2/3, if we were to put this cylinder in here, it means that outside this cone is actually 2/3 of space. We could actually fill that up with water. Let's see. We'll put too much in now. We can even put in a little bit more. So as we're pushing in, now I can't do it anymore. Okay. That was a bit too much. So what we can say around this cylindrical pyramid is actually, yeah, go on, shall I? I'm tempted to. Come on then. Okay, so now we can say that when I fill this cylinder with the pyramid, now it looks full, doesn't it? But let's take the pyramid out, and we can see that the cylinder is 2/3 filled with liquid. So that this is actually, if we were to put this cylindrical cone inside the cylinder, 2/3 of it would be taken up with just air, and the other 1/3 would be taken up with the cylinder. Okay, so we did see that it was about a third of 785. Let's actually check that we get 785 by filling this up to the brim as best we can. I know I'm going to spill most of it. Let's make it a little bit easier. Take a step back, everybody. We'll put it first in this beaker, I think. Oh, it was a bit better at that one. Okay, then we'll empty the measuring cylinder. And then we'll pour everything over to the measuring cylinder. And hopefully we should have about 785 millilitres, plus or minus a bit. I mean, it's not exactly rocket science we're doing here. I've got more on the table than I've got in the measuring cylinder. But if we measure off here, 600, 700, about 800, yes, just slightly less than 800. Well, actually slightly more. So this measuring cylinder isn't very accurate, but around 800 centimetres cubed. Okay, so the nearest, yeah. Really, the nearest 20, 30 millilitres is okay here for this level of accuracy. So we've looked at the volume of a cylinder, showing that the formula pi r squared times the perpendicular height actually does give us the volume. We've looked at the volume of a cone being a third of that of a cylinder. And, you know, I think sometimes it just makes it a little bit easier if you get to play with water. So if you'd like to play with any of these, have a go. There's also this one. Yes. There's a little hole in it. So we could actually fill it with water, and we could try and investigate what's the relationship between spheres and volume, and how would we work that out? Well, if we look at the diameter here, oh, what a surprise, it's 1 decimeter. Let's try and fill it with water and see what happens. I'm really going to make a big mess. Should have worn my lab coat. Here we go. Let's fill it. looks pretty, doesn't it? It's like a big marble. Okay, so it's full with liquid. Let's pour it into our measuring cylinder. And I'm going to tell you, yeah, what does it sound like? I'm going to tell you that there's a formula for the volume of a sphere, perfect sphere, and we'll investigate whether the formula is correct. The volume for a sphere has the formula 4/3 pi r cubed. Okay? So this is the formula to calculate. Well, we know that r is 5, so we're expecting the volume of liquid that we collect here to be the same as 4 lots of 3.14 times 5 cubed, all divided by 3. 5 cubed is 125, so we've got 4 times 3.14 times 125 divided by 3, which, Maestro, is?
Oh yeah.
No.
Divided by 3.
Please, not.
523.
523. Can we have a double, someone else to check as well? When I read off the scale here, we get 480
Well, it's correct.
centimeters cubed. But, I mean, a little bit of spillage, not quite perfect, but yeah, okay. This is the formula for the volume of a sphere. I would have expected it to be a little bit closer. I thought we filled it up pretty well. Could be that this measuring cylinder isn't as accurate as it should be. But yeah, so play with liquids and volumes and surface areas. And think when you're talking surface areas, you're just thinking about